Hey everybody, this is the second part to the video where now we're going to actually solve some inequalities. So what I'm going to do is I'm going to model 3 examples here, and I'll talk you through each of these examples. On this first one, you'll notice that we already have one side greater than or equal to 0. Since one side is already 0, I don't need to do anything special to the inequality. So I'm going to go right into the factoring. So we're going to have x minus 3 on the top, and on the bottom, this will factor as x minus 3, x minus 2. Okay? And now when I look at this, I can see, oh, there is a hole at x minus 3. So we know that x minus 3 cannot equal 0. So x cannot equal, oh, that wouldn't be negative 3, it'd be 3. Sorry. So x cannot equal 3. So when we do our number line, we'll have to make sure that we would take that point out. If we were looking at a graph of this rational function, there'd be a hole at that point. Then we have x minus 2 cannot equal 0. This is where we're going to have an asymptote. But again, we're not worried about what the graph of the rational function looks like. But we just know that we cannot equal 2. All right, so those things are not allowed. So those are our things in the denominator. My simplified function would just be 1 over x minus 2. And that would be greater than or equal to 0. So what I'm going to do now is I'm going to make a number line. And my critical values are going to be 2 and 3. So I'll put my 2 here and my 3 here. It wasn't allowed to equal either one of those. So I'm going to put open circles on the number line to remind me later that I use parentheses for those. By the way, we did not have any x-intercepts because my numerator is just going to be 1. There is no factor in the numerator. So there's no like x plus 2 or x minus 5 or something like that. So we're not going to have another point on the number line. Okay? So now what we're going to do is we're going to pick our test points. So my test points, let's see, I'm going to use 0 down here. I'm going to use 2.5 here. And I'm going to use 4 right here. And I'm going to use this simplified function. My numerator is always positive in each of these, so we really just need to see what happens in the denominator. So let's see, if I plug in 0 for x here, 0 minus 2, that's a negative. A positive divided by a negative means a negative interval. Plug in 2.5 for my x here, 2.5 minus 2, that's positive, and 2 positives divide as a positive. And then when I plug in 4 for x, 4 minus 2 is 2, that's a positive. 2 positives divide to be a positive. Our goal is to figure out when this function is greater than or equal to 0. So when we look at this, we don't want this negative interval. So for my solution, I'm going to have basically from 2 on, but we have to exclude the 3 because that's where the vertical asymptote is. So we're going to have 2 to 3, and then 3 to infinity. Okay, now remember, there was no x-intercept. There is no place where it will equal 0. That's why we don't have any brackets in this, okay? So this is our solution. All right. Let's try another problem on the next one. Everything is factored and one side's already 0, so that's beautiful because now we don't have to do anything special. We just need to actually start finding the excluded values. Let's see, nothing is going to cancel here. No cancellations occur, so I don't have to worry about any holes, but I know that this x plus 2 is in the denominator. We know that that can't equal 0, so that occurs when x equals negative 2. So x cannot be negative 2. So what I would do on my number line is when I have my value of -2, I would put an open circle on it. But we will have a couple of zeros. So our zeros are going to occur at this point and at this point. So 2x plus 1 will be a 0 when x equals, so we have 2x equals -1, so x would be -1/2. That's going to be a 0. And then x minus 3 equals 0 whenever x equals 3. So what I'm going to do is I'm going to take those critical values. -2 is the furthest to the left. I'm going to put an open circle on it. For my -1/2 and my 3, to figure out whether those are open or closed, I'm going to go to my inequality symbol, and my inequality symbol says just less than. So we don't want them to equal 0. Well, -1/2 and at 3, they equal 0, so we're going to put open circles on those as well. Okay? And now what we're going to do is we're going to figure out our intervals. So our intervals, we are going to have, let's see, I'll pick a -3 here. I'll pick a -1 here. I'll pick a 0 here, and I'll pick 4 here. Now, in our function, I'm going to use this function, factored form. Notice that we have a factor squared, so that will always be positive. So what I'm going to do in each interval is I'm going to figure out the signs as such. I went ahead and put my +1 in there because I know that anything squared is positive, so that's why that's going to be a positive factor. When I plug in -3 for the x on top, I'm going to get -6 plus 1, that's a negative number. And when I plug in -3 in the denominator, that will, oh, that I didn't even see that squared, so that will also always be a positive. So that'll make life easier for us. There we go. Negative times positive is a negative, and a negative divided by a positive, that makes that interval negative. And my next one, let's see, I'm plugging in -1 for x, so 2 times -1 is -2. -2 plus 1, that's still a negative number. That interval ends up being negative. Plugging in 0, 0 plus 1, that's positive. Everything's positive, so that interval is positive. And when I plug in 4, 2 times 4 is 8, plus 1 more is 9, so that's positive. That interval will be positive. All right, now to answer the question, we have to figure out when is this function less than 0. Okay, so that occurs in everything here and everything here, because those are my negative intervals. Less than 0 means negative intervals. So to answer this question, I would say -infinity to -2. I stop at -2 because -2 is where we're going to have that vertical asymptote. And then we pick up again from -2 to -1/2. And remember, it can't be equal to -1/2 because of the inequality symbol being just less than. All right, so this is our solution for that one. All right, let's talk about this last one. This last one is going to be the most involved. For this one, we have to make one side 0. So what I'm going to do first is I'm going to subtract this from both sides. So we get 3 over x plus 2 minus 2 over x minus 1 is less than 0. And now we have to figure out the common denominator. So when I look at my denominators, the common denominator, you just multiply these denominators, okay? So I have x plus 2, that means I need x minus 1. So I'm going to multiply the top, and I'm going to multiply the bottom by x minus 1. For the second fraction, I have the x minus 1, but I'm missing x plus 2, so I'm going to multiply the top and bottom by x plus 2. And I don't need to worry about doing anything to the right side because that's 0. So now I look at this, my denominator is x plus 2, x minus 1, and on top, I'm going to distribute this minus sign, goes with the 2, so I'm going to add the opposite here just so we can see that negative. So I have 3x minus 3 minus 2x minus 4, which that gives me x minus 7 and now we have everything that we need. So at this point, this is going to be a lot like what I did above. So let's find out, nothing cancels, so we're going to have these two values that can't be equal to 0. So x cannot equal negative 2. And we know x minus 1 cannot equal 0, so that means x cannot equal 1. X minus 7 can equal 0 and will equal 0 when x is 7. So I'm going to make my number line using those critical values. So let's see, negative 2, 1, and 7. Let's pick some test points. So let's see, negative 3, 0, 2, and 8. And nothing canceled or simplified in our function, so I'm going to use this form. Everything is just a factor, so we don't have any that are guaranteed to be one sign or the other. So I'm just going to go ahead and draw this out as such. These parentheses are going to represent the signs of each factor. And now I'm just going to use my test numbers to figure out the signs. So negative 3. Negative 3 minus 7. Whoops, I did my thingies backwards. These should, come on. Sorry, I should have had 1 on the top and 2 on the bottom. Let me fix that. Sorry about that. Okay, now we're on the same page. Sorry. So anyway, we're plugging in negative 3 for the x's, negative 3 minus 7, that's negative, negative 3 plus 2, that's negative, and negative 3 minus 1, that's negative. A whole bunch of negatives here. Negative on top. The bottom would be positive when we multiply those, but a negative divided by a positive, the whole region is negative. Okay. When I plug in 0, I get negative on the top, and I get positive and negative on the bottom. Just plugging those in for the x's. When I plug in 2, 2 minus 7, that's negative. 2 plus 2 is 4, so that's positive. And 2 minus 1 is 1, that's also positive. And then when I plug in the 8, 8 minus 7, that's positive. 8 plus 2, positive. 8 minus 1, positive. All right, I did not figure out the signs of my overall things, so I'll go back and do that now. So we already got the first interval. Let's see, I have the 2 negatives here and here in the second interval, so those would become a positive, so that region would be positive. On the next one, I have a negative on the top, and the bottom would be positive, so that region would be negative. And then on the last one, everything's positive, so that region will be positive. Now, what else I didn't do is I did not put my open and closed circles. The inequality says less than, so at 7, I'm going to have an open circle because we don't want it to be equal to 0, and that was the 0. For negative 2 and 1, they weren't allowed to be equal to those, so those are automatically open circles. And we want less than 0, so we're looking for our negative intervals. So my answer, which I'll do in green, is going to be negative infinity to negative 2. And then again from 1 to 7. And then we don't need anything else. So this is going to be the solution to this inequality. All right, we will practice a lot of these in class, I promise. Okay?